లాస్ట్ వచ్చింది సార్ అమ్మాయిని పుష్ చేస్తున్నాము ఆఫీస్కి రావాల్సి వస్తుంది. అమ్మాయి ఇంకా నాకు స్టిల్ లీవ్ ప్రాబ్లమ్స్ ఉన్నాయని చెప్తూనే ఉన్నది. ఈ మంత్ ఫస్ట్ వస్తామని చెప్పింది. సరే నెక్స్ట్ వీక్ థర్డ్ వీక్ వస్తాం. ఎవరైనా పంపించాలి టెక్సాస్.
Yeah, hi, good morning, all of you. Am I audible?
Yes, Veera, you are audible. Good
Okay.
morning.
Yeah, thank you. So let me share my screen. So did you practice yesterday one? Any questions on this?
Yes, we practiced, Veera. No questions.
Okay, perfect. So now, so yesterday we have practiced I mean, we have discussed on directly RDS, that is Relational Database Service, MySQL, right? So, and that front end back end is normal EC2 instances only is going to be communicate your RDS. I mean, if you are deploy any developers deploy any applications, front end and back end and RDS, your front end application is configured to back end application is configured to database. So that the three-tier architecture work like that only. So front end, back end, we are deploying multiple servers to get a high availability application, and to redirect the load, we are using load balancers. To increase the servers, we are using auto scaling. But in the RDS, we are not supposed to use an auto scaling group and load balancer. The reason RDS always one only, primary DB. To get high availability, so we have a concept in RDS, a multi-agent, high availability. If you can click that, that is taken care by AWS managed RDS backend team. They need to be maintain different, I mean, cloning kind of options in the background. And apart from that, we have a concept in read replica. So the read replicas are, we can create a read replicas from the master. So whenever you can create a read replicas from the master, always the read replicas sync with your master. So the data will be updated, master and read replica same accordingly. Okay. Okay. Next. So the same process in Kubernetes point of view. So, how the system will work. If I can take a MySQL pod directly, so how the system will work, we can understand. So, how the system will work here, MySQL. For example, let me show you the deployment at YAML here directly so that. So in RDS, we have a username, password, and endpoint to log in. Connect from the any third-party tool. So these three credentials are mandatory: username, password, and endpoint, like EC2, IP, and key pair. Uh, let's go to here the volumes concept. So if you can see here, this YAML file is not like our application YAML file. So in application YAML file, this database YAML file looks like similar only, but the difference we need to understand here. In this image path, okay, in this image path, we are giving our application image path, Docker Hub, or ECR path. But this is database. So database MySQL directly I'm taking image from the data Docker Hub registry. So yeah, here there are environmental variables like port. These are credentials. What credentials required to connect? So MySQL password, root password. So here there is no username. By default, MySQL username is root, and ports are here 3306 is the container port of MySQL. And next volume concepts we'll discuss now. So if I deploy this YAML file, MySQL pod will be created. If you want to log in MySQL pod, we have to give this password and username. The container port is 3306. Okay. And if you can see here, the volume mount pass will discuss now. In RDS, if you create any data, the data will be stored the background database volumes. See, whenever we can create a RDS, we can see this step, right? The storage. While creating RDS, we can see the storage to store your data. Let me show you here. While creating RDS, so here we are selecting the data, the size of the data, storage. Let me show you here the storage details. DB instance. Click on this here. So whenever you can, so whenever you can insert the data. So the data is going to be stored in 20 GB storage. So you can insert the records till 20 GB. So this storage is while creating instance, we have a hard disk, right? So here also the hard disk only, the storage. But in this case, this is RDS. So simply we are giving the storage access to store your data. But pod, coming to the pod, this is Kubernetes process, right? In this Kubernetes process, so in this Kubernetes process, so if I'm giving here password and username is by default root. If I'm giving username password, so if you want to connect the MySQL, once you connect the MySQL, if you write any data, the data has to be stored in somewhere, right? So otherwise MySQL pods will not be created. So we cannot create a database without storage option. But stateless application, whatever we discussed till now, the normal applications, front end and back end, whatever Python application, Node.js application, these are not hosting any data or storing any data, just applications only. So in those applications, if the pods will be deleted, new pods will be created with the same application by while pod creating time, the same image it is taking. So here also same only. But the problem is here, the pod has to store the data. This is MySQL means what? Upstream data has to store in database only, right? So that's if you want to store the data into MySQL pod, we have to provision volumes. So without volumes, MySQL pods will not be created. Whatever any database pods will not be created. So these volumes, we have a few options, 1, 2, 3 options: static option, dynamic volume provision, static volume provision. So static volume provision means like a Docker volumes. So the Docker volumes are not persistence, right? At that time, we have created a node path, Docker volume node path. So we can use the same container, same volume from the node. So here also we have a two different concepts volumes. One is host path and other is remote storage. Okay, remote storage means we have a similar options, few options in AWS to store the data like EBS volume, EFS volume to store the database data. So now, okay, in this case, the volumes are mandatory to create any pod. Okay, so these volumes we have at three types. So these volumes are three type, I mean, majorly two type of approaches we are following. One is for, so Kubernetes volumes are mandatory for stateful applications. Stateful means database kind of things. So mandatory for stateful applications. Stateful applications. Yeah. So Kubernetes volumes are mandatory for stateful applications. In this case, stateful applications means MySQL, PostgreSQL. These are. Okay, Postgres, etc. Database applications. So in this case, so volumes are mandatory. So volumes are mandatory means we have to create a volume path here and give the access to pods. Okay. So now volume paths, we have a two type of volume methods. One is for static method. Static volume method. We can give static host path. Host path. Host means node. Static host path means directly we can give the volume provision on node. So we are creating nodes, right? Directly pod can access the same node only. dynamic volume provision. So we have a two type of volume method, static volume method, dynamic volume provision. The first one is PV, persistence volume. And the second component is PVC, persistence volume climb. And the third one is main deployment at ML. So your deployment at ML is ready. So we have to create a volume provision to give access to deployment at ML to store the data. So this PV, let's take here. This is the PV persistence volume. This ML will help to create a volume on okay. So this is persistence volume creation ML. Whenever you can create a volume, so the volume path will be created on the node with 5 GB allocation. I mean, host path means what? Kubernetes get nodes. Two nodes will be created. Kubernetes, whatever. If you want to create a multiple nodes in the Kubernetes, those Kubernetes nodes will be created. Those nodes volume we can use for persistence volume to store the pods data into the node. So now the concept is whenever I can execute this, one volume will be created in the node. Okay. Next. One more ML. This ML is help to provide the volume provision to deployment. I mean, if I use this persistence volume climb, if I use this, I mean, this is your climb. This is created volume. You are going to climb this volume for your deployment. I mean, this deployment, if you can see my deployment, we'll get a clarity now. So I'm taking from here only, rest above island you need, right? So copy. Yeah. So guys, here your Kubernetes is using persistence volume climb. Sorry, your MySQL pod is using persistence volume climb from here. So if I deploy this AML file, I'm using this volume climb. This volume climb is calling this PV. So physical storage will be created whenever you can create a PV. Okay. So this is climb. This climb will help to give a allocation, created volume allocation to deployment. So this is actual volume created. I mean, actual volume is registered on the node, this path. This is helpful to allocate created volume on the host to deployment at ML, this climb. So I can use here 1 GB, 2 GB, 3 GB, 4 GB also climb, but not possible to 6 GB. The reason this climb is taking volume from PV, persistence volume only. This is limit is 5 GB. If you give 10 GB here it is possible to use 6 GB. I mean, for example, my deployment at ML only required 1 GB, but you are created a volume 5 GB. So you need to write a persistence volume climb for 1 GB. So this climb calling in the deployment at ML using 1 GB only. Still you have a 4 GB. If you want to increase the storage capacity, go to volume claim, increase 1 to 4 or 1 to 5. But it is not possible to 6. The reason physical volume created only 5 GB on the host. First, what you need to do, increase the volume here and then give the claim here and they call in the deployment time. So this is the process in static volume calling the deployment at ML. Okay, let me try now so that we'll get. And a very important thing, guys, here. My deployment at ML is calling directly PVC, right? But PVC will call your PV based on the two things. The number one is based on the storage, and number two is very important is access mode. Based on the access mode only, it will communicate PV-PVC. For example, your PV is read access mode read write once. Your PVC is not read write once, read write many means this climb is not linked to this PV. Okay. Yeah. And one more thing, for example, one pod is created. A MySQL pod is created. MySQL pod using this AML, this climb. One more pod is created. One more pod also volume required. For example, different pod volume required. In this time, it will not be allow any conflicts. The reason this PV already bind on PVC. So in this case, you need to be create one more PV for different pod. In this time, you can give different, in this time you can give same AML also, no problem. Same AML also, if you create means this storage will show uh, free now, not bind. Free means you can use this PV to any one more pod, but we cannot directly use this volume to this pod. Again, you need to write a PVC for next pod also. So PV, PVC will interlink with based on the access mode only. But here may you can get a doubt. Here also PV is there, here also PV is there. Both access modes are read write ones. Is there any conflicts? No conflicts. The reason read write ones already allocated to climb. This climb already bind on deployment at ML. In this case, this PV is busy with PVC, PVC is busy with this deployment at ML. So next pod, this PV is not allocated, your API controller is not allocated this PV to any other pod. So no conflicts will come. Again, if you create a one more PV with the same options also, controller will give this PV to next pod. The reason this PV is not attached to any PVC. Okay, clear or any questions?
Here, Veer.
Yeah, may you get a doubt? If I create one more PV, this PV, in my end, two PVs AMLs are there. Kubernetes may confuse to attach this which PV. The reason PVC is not calling any labels, only calling through access modes only. In this case, if I create a one more PVC for different what I'm talking about. If I create a one more PVC, so may conflicts will come, but this PV already busy with this deployment. So Kubernetes will not allocate already busy PV. So only free volume only Kubernetes will allocate. At this time, this volume is free. So Kubernetes will allocate this volume to one more PVC. You have to write one more PVC. And PVC we can call the deployment.yaml. So this PVC name is persistence volume climb. The name is MySQL PV climb. Here you can write MySQL volume PV climb to different volume. So you can use the deployment.yaml MySQL climb volume to like this. No conflicts will come. Clear this concept, the conflicts concept, it is not, we are calling only access modes only. And again, one more thing, for example, your PVC, if you give 50 GB here, let's an example. So Kubernetes controller will verify any PV is there 50 GB. If it is not there, it will not create it. Okay. Let's start the process. Okay. So now cd date and volumes. So ls. So a static host path. I'm going to static host path. Static host path will create on node. Okay. So let's practice one by one now. Kubectl delete -f dot. I'm going to delete if anything is there in this. Sorry. Okay. So kubectl get PV. I'm checking any PV is there in my node. No PV. What about PVC? So there is a one PVC in pending state. I'm going to delete this PVC. I don't know when it is created. 4 days back. Kubectl delete PVC. Give the PVC name. Same process, same commands. All are done. So my nothing, no PV, no PVC, right? So now kubectl apply -f pv dot ml. Yeah, kubectl get PV. So your PV 5 GB is available. Okay, your PV 5 GB is available. Now this 5 GB is available means Kubernetes can give this 5 GB to any deployment. If I write a PVC now, if I write a PVC, so Kubernetes will give the this PV to your PVC client. I mean this volume is ready to use. Okay. Now what we can do here? Let me check the pv.ml. So 5 GB host path is MNT data. I mean mount data. Now 5 GB PV is ready, but not at create at this time. So when it will be created, whenever you can create a deployment, this 5 GB also will create on the same node where exactly pod is going to be scheduled. Okay. So now if you want to check, maybe my end it will show different activities I'm working at. Yeah. So these are my nodes, guys. So two nodes are running in this node, any one of the node. So any one of the node, the host path will be created. Okay. But if you can check your AML file. So yeah, whenever I can create a pod, the pod mount path volume is varlib mysql. I mean, if I give here, this is node, guys. Don't confuse. This is node. This is node. So let me check here. CD var no ls cd var ls and what is the mount path lib mysql. cd mysql. So mysql is not found here. Okay, try to understand. And let me open one more node here. You open one more node. Just close unnecessary tabs. Yeah, I'm going to connect one more node. Node path means volume should be created on these nodes only. cd var cd lib. Is there any MySQL? No. The reason not yet deployed my MySQL. Okay. And let's go to, I will explain beta. And two nodes cd mnt cd data. Yeah. Let's go to again here. This is one more pod mnt cd data. Perfect. Okay, guys. So my PV, okay, my PV will create. Let's go here. Let's go to now. We can verify now. My EKS cluster. This is my EKS cluster. So PV created, right? Now PV created. Now I'm going to create PVC also. Okay. Now I'm going to create a deployment also. Okay. So kubectl get pods. Okay. My MySQL pod is running here. Remaining you can ignore it. My MySQL pod is running here. So this is database, right? So you just understand your RDS is running. So yesterday, if you compare with yesterday concept. So after that, if you want to insert the records, you need to connect from external by using SQL Workbench. You can insert the records. So the records will be stored in primary DB in the volume. So here, if I insert the records are going to be stored inside the volume path already created before. Now, how to log in the pod? kubectl exec-it bin bash. Okay, I'm inside of my pod, guys. I'm inside of my pod. So if you want to connect MySQL, client, I mean, if you want to insert any data, first you need to log in MySQL client. So in the Linux command to connect MySQL database, any database, MySQL, I mean, this is MySQL database. Any database means DB on EC2 or RDS, whatever it is. This is the command to connect your database through CLI. So root username is root -p. So if you can give like this command MySQL, my user is root my password is -p. So it will ask the password PASSWORD. I have given my password. Okay, if you can see here, deployment.yml, MySQL password also value is password, but username is by default root only. Okay, let's go now understand here. So you are inside of MySQL. Now same you can run the queries. Create database. You can create database name is DevOps. So give the colon. So query OK, one row affected. Now how to check the database? Show databases. These are commands only. If I check, see DevOps database has created. Okay, DevOps database has created. Now we need to understand this DevOps database created on, to create a DevOps database. So if you insert any volume, whatever, any records, these volumes, these records are stored in host volume. Host volume means node path. Let's go and check which node it has created. Let's understand exit from here. Okay, kubectl get pods -o wide. If I check, let's understand where my pod exactly running. So MySQL pod, this is MySQL pod running on, excuse me. Okay, this is, okay, kubectl. Okay, we can see here also. MySQL pod is this one. Running on 54,243. 54,243. Let's go. Any 54,243 IP private IP is it? Not this one. Go to one more node. I think first one. No, I think wrongly checking then. Okay, kubectl. This terminal is coming like this. This is a pod. Let me check then describe. Kubectl describe pod. So these details I'm describing to check the node details. The dashboard is not giving here exactly. Okay, here we can see where exactly your node is running. So 240 private IP. Yeah, node. Yeah. So 240, not 243, 240. Let's go. Not this one. Yeah, 240 is here. So it is running on this node. So, okay, this node already connected, right? 13,127. 13,127. Okay. Let's come back. Okay. Where exactly volumes will be stored? We have given the volume path is what? pv.ml. MNT data path, host path is here. Your volume storage 5 GB is allocated on this host path means node path, MNT data. If you create any deployment that in the deployment pod, any create records, those records will be stored and host this path only. Which host? I'm able to see two nodes, right? Where exactly? Okay, let me check, then we can decide. Okay, let me check. My pod is running this node only, right? My pod is running in this node only. 240 means 113, 127. Not this one, not this one. Yeah, here only. So let's go and check created DBs there are not inside. ls cd mnt mount path cd data ls. See here, guys, if you can see, DevOps is created now. Let's go inside DevOps. Okay, so nothing is there inside. Just created empty database only, right? So for example, if you insert any data here, I'm logging again. So MySQL -u root -p login process. Password connected. So you just create a sample table here. Create a table. MySQL yesterday we have taken right already. Okay. So create, see command also MySQL -u username password login and then run this one. Okay. So yeah, you are here, right? So execute this. And here you have to give it is not going. Okay. Control C. Let me paste any notepad first and we can. Here database name is about DevOps. So if you give like this employee table will be created in DevOps database. Copy. Query okay. Rows no, okay. Now we can check the show tables. Rows 0, but table is created, right? So let's go now. Here, refresh. CD, MNT, LS, CD data, LS, CD DevOps database inside LS. See, employees.ibd table is created. VI, this is, we are unable to understand. This is encrypted format. Okay. Yeah. And again, we can check one more node, right? We have a one more node. We'll see they are also created or not. This is one more node. CD, CD. Okay. Where should I check? CD, MNT, LS, CD data. Okay. Now here, see, I'm unable to see DevOps database inside, MNT data inside. But that node we are able to see. The reason Kubernetes by default, wherever pod is going to be created, same node host path will be created for 5 GB data, 5 GB volume. So whenever 5 GB volume is ready, right? So this 5 GB physical volume, MNT data path is ready. But this volume will be created whenever pod will be deployed. Pod will be deployed on which node? The same node this volume will be created. But your deployment at this time not required 5 GB. Need only 1 GB. In your climb, you can update only 1 GB so that your deployment pod will take only 1 GB. But here I have a one question. So for example, may you also get the same question. For example, let me go to my EKS. Yeah, here. Exit from here. and again exit from bash container, kubectl, I mean pod, kubectl delete, okay, again get pods or delete pod. See, pod has deleted, right? Kubectl delete pod has been deleted. Now kubectl get pods. One more pod will be created immediately as per the deployment. See, 11 seconds ago, guys, you tell me. I mean, just we need to understand here. This pod this time, if it will create in different node, so definitely we won't get the same data. The data has stored, previous pod data has stored in some node, right? But new pod, high availability, whenever pod deleted, immediately pod will be created. But this pod hasn't created, maybe that scheduler default, by default it will create any one of the node, right? So for suppose it will create a different node, we won't get any access of the volume, right? Definitely we won't get the access of the volume. So what we can see now, let me check where exactly this pod has created. Kubectl describe pod. Okay, let's go here this time. Which private app it is taking? 124. Let's go just for map 124. See, whatever. mm, sorry, 151. 151. Wrongly checking. Not this one. Yeah, 151. So 3111 pod node. I have a login line 3111. Yeah, here. So now, so here before no database, right? Okay. So now new pod has created this node only. See here. Now, so what we can understand, my database already having data. So simply if you log in this pod, like, yeah, simply if you can log in kubectl exec -it. Yeah, if you give the pod name here as usual. Okay, now as usual, I'm going to log in MySQL -u root -p. If I give password, I'm able to inside of MySQL. So I thought create a database, show database, show databases. If I give this query, see my node DevOps database is there. But what I thought, if DB will be deleted, again same DB will be created with the same data. But the problem is here, see, in this part, no data. But what user can understand, I have already inserted data, right? Why data is not there? The reason, Kubernetes controller, I mean Kubernetes API scheduler is schedule the new pod on different node, not in the same node. How we can overcome this situation? Simple. Oh, so if you want to create a one more pod, I mean deleted pod on the same DB, what we need to do here? So we have to write a node selector or node affinity rules to create the pod in the same node. But even you see, at the time also, whenever pod will be deleted, it has to be created immediately. So in this case, if you write a node selector option, for example, node selector for this pod, so immediately pod will be created same node, volume will be created same node. If the pod will be deleted, again pod will be created same node. There is a node selector, or you can use the node affinity. So by using these options, we can map the volume into the same node always. Okay, this is the process. Till here clear or any questions?
Veera, I have small doubt.
Yeah.
These 5 GB volumes from which it is allocating to pod.
Sorry.
The 5 GB volume is right. 5 GB data volume. From which resources you are allocating?
5 GB per which resource?
Yeah, the in pod volumes 5 GB is there, right, for allocating volumes for data.
Hmm.
From which resource it taken?
MySQL only, MySQL pod. This is for MySQL pod. See, MySQL pod is a database, right? So
Yeah.
database means what? Store the data. To store the data, I need some volume, right? My pod requires some volume to store the pod data. Pod data means what? Users can access, the user can sign up, user can add the data means database has to be stored. For example, so if you purchase something into the Flipkart, so if you purchase some, products, so if you want to check after 1 month my history, the products has to be stored in Flipkart database that user able to access. Now, for example, same my pod is running, Flipkart pod is running, Flipkart pod, we are accessing through front end, we are insert the data into the Flipkart pod through you front end. So after 5 day, if you can come and access your data, if data is not there, that is not good, right? So the pod has to be created different node. But user, while inserting the data, pod has running a node one so that he is able to access. But later pod has to be deleted. Again, new pod immediately created, but new pod created, but the created pod is created in different node, volume has created in different node. So this concept is very difficult. I mean, this is not a high availability concept, reliable concept. So what we need to do, if you want to create pod in the same node to access the same data from the node host path, so we have to write a node selector or node affinity rules. Clear?
Yeah.
Yeah, this is for MySQL database. Volume are using for MySQL database, but MySQL database runs on pod, not in RDS. This is running on pod in the form of pod. Yeah, clear or others? What about us? No questions? Okay. Okay. So this is a stateful concept, guys. So also we can use node selector or node affinity rules for to create a pod in same node. Already we discussed, right? Or we have a one more way, guys. And also we have one problem here. Maybe node will be deleted. For example, node will be deleted. Volumes are stored on specific node, right? Every data, whatever data is going to stored by pod, the data also lost. Enter data also we are going to lose. So in this case, what we need to do? So this approach is not at all recommended for real time. So we have a one more approach is a real time approach, dynamic volume provision. Dynamic volume provision is this is the concept. Okay. So dynamic volume provision, we don't have any PVPVC concept, directly only one concept, storage class.yml. This is storage class.yml. So this AML is, so dynamic volumes are nothing but what means. So we are using isolated volumes. So isolated volumes are nothing but, if you can go for ESOT instance, we have a volumes here. We are using this volume directly. We are not attaching any node. This volume centrally stored volumes, not depends on any node. So your pods directly access this volume. So create a volume, pods will be created a volume and store the data in this volumes only. Okay, so you can create a volume. For example, minimum GB is 1. So if I create a volume here, see one volume will be created now, 1 GB volume. But where exactly these volumes are stored? AWS backend, not in any EC2 instance. So if you require this volume, you can attach to EC2 instance also to store some data. If I attach pod will store some data in this volume. This is centrally storage volumes called elastic block storage. Okay, these storages are elastic block storage volumes. So dynamic volume provision is nothing but whenever pod will be created, immediately one volume will be created here automatically. Pod has map with this volume. Whenever data is going to be stored, the data is going to be stored in this volume only. Even node will be deleted, even cluster will be deleted also, still volume will be persistence. The reason volumes are external storage, not in the part of cluster. We are accessing, pod is going to be access the volumes from external, so that these volumes will not be deleted. Whenever cluster will be deleted, node will be deleted. So we can use as a backup option. So we can use the same volume for new cluster also if you want. So these volumes are not in the part of any ESOT instance, any cluster node and all. So whenever node will be deleted, pod will be deleted, doesn't we don't have any problem. Simply the volume will be used same volume. So I'm creating volume manually, right? This volume also created by your pod itself. Okay. Let's go to understand now this concept. Little difficult, guys. Volumes concept we need to practice here. Yeah. So here EBS storage, we are using EBS storage AML. So this AML, meaning of this AML is create a one volume in EBS type GP2 volume type EBS volume. Okay. If I run this AML file, one EBS volume will be created directly. That this storage class we are calling from the deploy.aml. If you can go, I'm calling here storage class name, the specifications. Before we have use PVC's concept, right? PVC. Now this is storage class concept. Storage class, which storage class? EBS volume. This EBS volume is not part of in the cluster. It's a external part. Okay. So let me apply now this. We can see what will happen. kubectl apply storage class. kubectl apply -f sc.ml. And before that, what we can do, guys, better clarity. Let's go back. kubectl, go to static path, delete all the things here. So kubectl delete -f dot. If I give, everything will be deleted inside PV, PVC and pod also. Apply -f dot means everything will be applied. Okay. So kubectl get PV. Let me check PV is there or not. Okay. So kubectl delete PVC. So get PVC. Okay. So this is bound, right? So kubectl get pods. Still MySQL pod is running. That is a problem. kubectl delete pod. I'm deleting pod now. Excuse me, kubectl get PV. I'm going to delete PV PVC also. Kubectl get PVC. So PV PVC volumes are created to for deployment of MySQL. Now I'm deleting MySQL also, right? I'm deleting PVC PV PVC also. Just deleted this one. Kubectl delete PV also. I'm deleting PV also. SQL PV. Okay, I have cleared everything. Let me start with storage class process. So terminating process, it will take some time. kubectl get PVC. Okay, PVC deleted. Okay. This is also terminating process. So let's apply now storage class process kubectl get sc. Okay. So I have applied storage class right here. LSCD dynamic provision ls. So I have applied storage class right here. So this storage class has created now. No, this is created 2 days back. Okay. kubectl apply, sorry, ifnf sc.yml. I'm just creating a storage class. Okay, created. Now kubectl get sc. Okay, my storage class has created 6 seconds ago. So this storage class, if I created means EBS volume is not created. If I go here and check, see no volume has created. When the volume will be created, whenever deployment will be created only. So yeah, if you can see two options we have. First is volume bind method, wait for first consumer. Wait for consumer means whenever deployment time will create only this volume will be created on EBS volume. There is no limit guys. We can unlimited storage we can use here. And immediate means if you run immediate means volume will be created immediately. If you give immediate instead of wait for first consumer. But whenever when we can use this volume whenever deployment has to be created only, right? So wait for first consumer means after create pod only volume also will be created parallelly. Okay, let's understand now. kubectl apply -f deploy.yml. Now kubectl okay. So my MongoDB, this is MongoDB instead of MySQL is pending state. So kubectl get SC. Okay, my storage class also created, and even let's go to here my deployment.yaml. So I'm calling my deployment.yaml. See, this is in place of MySQL MongoDB. I'm calling same process, username and password also MongoDB and mount path also. Here, if you can see, I'm calling what here storage class. I'm using only 1 GB. So volume claim template, if you're using, if you need 1 GB means you should create a volume claim template. But if you observe here, this volume claim template I have added inside the deployment.yaml. Otherwise, copy this one from here. What we can understand, copy from this here, and we can create a volume claim template. For example, not here. Yeah, for example, storage is there. Here storage is equal to storage class is equal to PV. Before case I'm saying that. And storage class inside there is no any, there is no any storage options. Storage capacity options. See, just given only. But how much volume required for my deployment.yaml that will be decided persistence volume claim. So if you observe my persistence volume claim, just for understand purpose only I'm created like this. So here you can create a pvc.yaml. No pv.yaml here. In place of pv.yaml, sc.yaml is coming. sc.yaml is refers to EBS volume. pv.volume is refers to your host node host path. So now pvc.yaml, if you create additionally, you can paste it your whatever you have given for your inside deployment.yaml. So this PVC also I'm adding inside the deployment.yaml. You can use inside the deployment.yaml also. What I'm trying to say here. Go to little one step back. Static host path. If you can see here, deployment.yaml is there, right? Here I'm calling my PVC volume, name. So here already PVC there, so it is calling required 5 GB volume from the PV. Or I can take this entire copy, I can use inside deployment.yaml only here instead of calling. Enter PVC also here. Creating separately PVC and calling PVC in the from the deployment, or you can add PVC in the deployment itself also. Both are same. Okay. Yeah. This is it is going on. Now, if I go and check why my pod is pending, we need to debug now. So the problem is here, kubectl okay, my PVC is pending. PVC is pending means what? Why PVC is pending here? Kubectl describe PVC. We'll check why PVC is pending here. Copy, paste. There is some information warning here. Okay. No policy allow or not this status code. We just understand here. We have to give no identity base policy allow to create a volume. Okay. Authorization failure. Okay. So here what we need to do, this ARN not authorized to create a volume. So this is looks like your node ARN. Let's go and check. Copy. So whenever EKS cluster nodes will be created, so this volume has to be accessed from the node, not this EC2 instance. The node is missing some permissions to create a external volume. So node inside pod is running, right? So this node pod is running inside the node means this node is able to connect first EBS volume which is are outside of the cluster. So this node is trying to create a through pod is trying to create a volume, but unfortunately we are missing some permissions. Not see user ARN is not authorized to perform to create a volume on this rows. Okay, on this path. Okay, so let's understand here the user is here. This is the user. Let's go and try to find out this role from IAM. Whenever node will be created, this role will be created. Roles. Yeah, go here inside. This is the role is missing any permissions. Okay, here I'm going to give a permissions. Let's give no admin permissions. Okay, let me give admin access for this role. Add permissions, attach policies. We can give simply easy to full access also. We have attached policy, we can see. This is not easy topic, guys. Maybe PVC is little contact process. Still pending. Okay. kubectl. And one more thing I need to discuss here. Actually, guys, your cluster is trying to connect volume outside. This is not inside the cluster. Here, two things we need to understand. The cluster first should have a permission. Cluster inside nodes should have a permissions to create EBS volume. EC to full access or admin access you can give, no problem. But first, EKS is able to access EBS. In this case, we have to install EBS driver. Actually, the process is. But I'm not installing EBS driver. I'm directly trying to create a volume. But here, if you go for process document, there is a process here to, install the driver here. See, first we need to install the driver here and then install the CSC driver process and all. But without installing driver, I'm trying the reason. If you go for EKS dashboard here, we have a new option is enable a few days back. Yeah, my cluster is running in Mumbai. This is my cluster, right? Here access, if you can go, there are add-on, right? If you go manage access, yeah, if you go for add-on, so I have added a direct. Okay, here is not there now. That's what. Okay, that is different. Click on add-on here. Okay, so I'm going to check here. I need EBS driver here. I think I have already added. Let's go and check. Yeah, EBS CS driver already I have added here. For example, if it is not here, okay, go to access here, click on add-on. So any drivers are required, you can add directly from here instead of installing directly. For example, you can give the mount path S3 also. So S3 CSA driver, no need to install from the external. You just click here and add here means so S3 CSA driver also added here like that. If you can go your add-ons again, so access add-on. After adding, we are able to see add-ons list your S3 also. I think it is creating mode, adding mode. You just refresh. This EBS driver loading anyway. EBS also have added same like the process. Okay, S3 also added. See, EBS also added, so it should work now. Oh. It's taking time. Yeah, it is connecting. Cube CTL get parts. Okay. So this is running. Let's go and check volume has created or not. See, volume also created. Okay, sorry. Cluster is running in Mumbai, right? We have to check here only. Yeah. Okay. Dynamic volume is created 1 GB. I mean, this volume has created through deployment. Okay, first what you need to do for this practice, apply the storage class, and before that go to the EKS cluster. This is very easy process. Instead of installing the driver, go here. The first step is open the cluster, click on access your end, not add-ons. Add-ons are you are able to see after add the list. Go to access, come down here, add on, click on this. So click EBS CSA driver, EBS. My end already added. That's what I'm able to see here in the list. EBS CSA driver is required. So in earlier, actually, we used to install on directly by using some commands, but now simply we can add. So if you add, after that, apply the storage class. Okay, apply the storage class. Whenever you can apply the storage class, so EBS volume is ready to create. Whenever you can deploy this process, immediately EBS volume will be created. But EBS volume is created outside of the cluster. So if you delete this deployment process also, still volume will be exist here. If even delete the cluster also, still volume will be exist. So this is access volume from external. So your DB details, everything will be stored in this volume only. But we are unable to check this volume inside the data. So this is just volume only. If you attach this volume to any server, same like the process, you can connect and we can check like that only. Okay. So this is the process of volumes and DB, how to work with DB inside the pod. Okay. Any questions?
Yeah, Veera. We'll try to practice today. If we face any errors or something, we'll ask you tomorrow morning in the morning
Yeah.
class.
Definitely the reason this is little difficult task, you need to practice only. So you just my repository already there, right? First practice host path. You just ignore this static load path. We are not at all using. Just we have approach. That's what updated. If you're interested, you can go it. But important one is only real time dynamic volume provision. What we did. So just dynamic volume provision. First apply the storage class. The storage class will be created. This storage class is to create a EBS volume. Okay. This YAML file is to create a EBS volume inside your AWS. But this EBS volume, when it will create, wait for first consumer. Means what this meaning? Whenever pod will be executed only, this storage class will be created EBS volume. Or if you can change immediate means, whenever you can run this YAML file, immediately volume will be created. But always recommended action is wait for first consumer only. If you create with first volume, if the pod is not deployed, unnecessarily we have to pay for volume cost. So apply storage class and then apply deployment.yaml. That's it only. And before that, you need to enable EBS driver access in the EKS. 3 steps you need to follow. Okay, so thank you so much. Please practice, guys. This is little important and difficult task. If you are facing any issue, tomorrow I will repeat the same concept. Don't worry. Bye bye. Thank you.
Thank you, Veera.
Thank you.
Yeah.